Hello everyone. Welcome to Engineer and Educator, your one-stop destination for mastering engineering concepts. In today's session, we'll be starting with the very basics of electronics, that is active and passive devices. See, this is the first topic in electronics engineering and a frequently asked concept in Kerala PSC Polytechnic Lecturer Exams and other competitive exams. So, by the end of this lecture, you will understand the fundamental differences between active and passive devices, and you will learn their characteristics and applications. And after that, we will be discussing some questions, some MCQ questions also. Okay, first, what are electronic devices? So we are going to study about active and passive devices. Obviously, you know that they are electronic devices. Okay, some basic electronic devices. So, what do you mean by actually electronic device? The components that influence the flow of electric current in a circuit. The components that influence the flow of electrical current in a circuit is called as an electronic device. Any component, if it influences the flow of electrical current in a circuit, we can say that it is an electronic device. And these electronic devices are classified into active and passive devices. Okay, electronic devices are classified into active and passive devices. Next, we will be going to see what do you mean by this active devices. So, in any electronic device, in any electronic circuit, the components are categorized into two, that is active and passive devices. Of that, we can here itself I can say the definition of this passive devices and active devices. Passive devices means these devices, passive devices by themselves, they cannot control the flow of current. Okay, this passive devices cannot control the flow of current. So they only store or dissipate energy. So passive devices, so as we have seen here, uh, passive devices by itself, they cannot control the flow of passive devices, means this one, this part. This passive devices, that is here. That is here you can see here, I have written passive devices. Now, this one. This passive devices means that this passive devices itself, they cannot control the flow of electric current flowing through the. What they can do is that they can either store or they can dissipate energy. They can either store or dissipate energy. Dissipate energy. They cannot control the current flow. They cannot control the current flow. Another thing is that active devices. Active devices on the other hand, what about active devices? These can control current. They can active devices on the other hand, they can control the current. Control current. They can control the current, and also for that they require an external power source. An external power source they require, and they require an external power source to function. Okay, active devices and passive devices now we have come across. For example, you might have heard about resistor and transistor. Okay, resistor, it simply reduces the current. What does the transistor do? Transistor is an active device while transistor can amplify that. Okay, And for that, now we will we'll see about some active devices. Okay, first we will be dealing with active devices. What are these active devices? The devices that require an external power source to function and can amplify or control the current. Okay, so it is a actually what is that? They are okay. So the devices that require, see, the devices that require an external power, that require an external power source to function and they can amplify or control the current. They are known as these active devices. Okay, the devices which can the active devices are that require are the devices that require an external power source to function and they can amplify or control current. For example, I can say that examples are here some transistors, some diodes, a light emitting diode is given here. Diodes, you have seen the symbol of diodes like this. Um, and what I have given here is the light emitting diode example. Some transistors are given here as an example and these transistors and also some ICs. ICs in the sense I can say about the operational amplifiers and all integrated circuits. Operational amplifiers also and also integrated circuits. These are all examples of what integrated circuits and op amps. You might have heard about op amps like this, some kind of things like uh, circuits you could have seen like this that we'll deal with it in later classes. So these are the things that are called as active devices. Definitions you have got. Next, we will move on to definition of passive devices. I also already told you definition of before going to that. I can say some examples for. So this is about active devices. Now about passive devices. Just think passive devices means the devices that do not require. Passive devices are the devices that do not require. But passive devices are the devices. Passive devices are the devices do not require. These devices they do not require an external power source. They do not require an external power source and they cannot amplify. That's another point here. That is, they do not require an external power as well as they cannot amplify any signals. Resistors, capacitors, inductors, and transformers are examples of passive devices. There is, I have given a resistor figure and a capacitor, and you can see many different types of transformers are given and later on we will study about transformers in detail. Iron core these are not transformer, these are inductors. Transformer image is not like this that I have taken away from this. Transformers are also examples of passive devices. Different types of inductors are being given here. Okay, let us move on to the next topic. Okay, active devices. You need an explanation and examples on regarding the active devices. Okay, I will tell you what are active devices. Active devices. When we come across active and passive devices, first I discussed about active devices. Now we are going to study the different explanations. What are active devices? Okay, for that, uh, active devices, if you tell what they are active devices are some electronic devices that require an external, they, what we studied at first that they are they are active devices. Now let's move to active devices. Active devices means we studied that any active these can control current. They require an external power. Yes, they require an external power. So we will be studying on the examples of these active devices. Okay, active devices examples. if I am telling about this active devices, first active devices will be active device slash that is diodes. You might have heard about first active electronic components. So these are the devices which are capable of amplifying or processing the electric signals, and they are called active components. And this function, and they are, another thing is that the active components include these devices called examples for these active components are we can say that examples for active components are like um, active components examples, I can say that they are diodes as an example for active component. And this the active components include also vacuum tube devices, gas tube devices, and semiconductor devices. Presently, semiconductor devices have almost completely replaced the tube devices in low power applications, but in high power applications, these tube devices are still being used. And important active devices are here. The first active device is semiconductor diode. Okay. The name semiconductor is derived from the fact that its conductivity lies between that of insulators and conductors. Said diodes. So different types of diodes you can see. See this. What is the purpose of this diode? A semiconductor diode. It allows what? It allows current flow in one direction only. Semiconductor diodes allows current flow only in one direction. Semiconductor diodes, these diodes allow current flow in one direction. See, current flow can be taken place only in one direction. So they allow current flow only in this active devices. First among active devices is diodes, and they allow current flow in one direction only. And as a result of that, they can function. Their function is to allow current flow in one direction only, and they are used in rectifiers. So what is the function of a rectifier? What does a rectifier you do? This rectifiers, they converts alternating currents to DC current. So we use this diodes in place of in order for rectifiers, use in rectifiers for anode. And so this diode will have a anode and cathode, a positive lead and a negative lead. And here you can see different types of diodes are given: signal diode, light emitting diodes, IR, LEDs, photodiodes, transient voltage suppression diodes, Schottky diodes, see Schottky diodes, tunnel diodes, varactor diodes, pin diodes, laser diodes, silicon controlled rectifier. See from this example itself, you can see that silicon controlled rectifier, SCR. So we can understand from that diodes are mostly used for what purpose? They are used in rectifiers. So we will move on to the next slide. That's on another active device, which is that active device, that is transistors. So what is the function of a transistor? In most of the electric circuits, a transistor is used as so what we will what purpose is this transistor used for? They are used as switches in electrical circuits. So transistors are mostly used as switches in electrical circuits, and the transistors, their function is to amplify. They act as an amplifier. Either they will act as an amplifier or as an electrical signal. So don't forget, diode is working as most of the time. Diode is working as a rectifier. It because it allows current flow only in one direction. Transistor, on the other hand, it acts as an amplifier or a switch for electrical signals, or a switch. And some different types of transistors are there. BJT. This BJT transistor itself can be of two types. BJT, bipolar junction transistor, and or is of two types. NPN transistors are there at the same time. You can say PNP transistors will also be there. Then MOSFET, metal oxide. MOSFET means metal oxide semiconductor field effect transistors. See MOSFET, another example. Then JFET and IGBT. So these are the different transistors that you see. Then operational amplifiers. Next, Next topic is about, sorry, so I'm not dealing with operational amplifiers here, but operational amplifiers can also be called what as active devices, and these operational amplifiers are usually they are used in signal processing. This is not the picture of operational amplifier. This is the picture of an IC. Okay. IC means integrated circuits. Before we studied transistors, and purpose of transistor is to function as an amplifier and a switch. It amplifies and it function is you it's just an as an amplifier or a switch. Integrated circuits. Next one is integrated circuit. An example for active devices. Multiple electronic components are integrated into a single chip for complex operations. So you can see here, here I have given a picture of the internal structure of an IC is given here. You can see it, multiple electronic components are here, and these components are integrated onto a single chip. So this everything is integrated, or you can see integration means to sum up. So like that, every electrical components are summed on a single small chip, and that is called an IC. So integrated chip. So multiple electronic components integrated into a single chip for complex operations, and among that, an example you can call as some microprocessors and operational amplifiers. You can see here some microprocessors and also op-amps. Op-amps you will later study. Operational amplifier means they are used in signal processing circuits, and they are used in audio amplifiers. So these are also example for what active devices, integrated circuits. So op-amp is an integrated in IC. Okay, next one. Uh, Next, we'll be moving on to vacuum tubes. So, relatively, this is an older technology. If I tell you, this is actually an older technology. Uh, this was previously being this vacuum technology. I can say this is an older technology, and the vacuum tubes. This is an older technology in the sense I'm telling. This vacuum tubes were used in function means vacuum tubes were earlier they were used in radios and televisions, and before the invention of these transistors and all, we can say that big vacuum tubes were used. So their purpose was to uh, amplify signal amplification. Okay, this is also an example of active circuit, active devices. Next, we are going to deal with passive devices. Okay, passive devices, this cannot control current flow. We told that they controls the flow of current by offering rays. Before that, this passive devices means in any electronic circuit, passive devices itself means that they cannot they cannot control current flow. They store or they resist or they dissipate energy. One such passive device is called resistors. Here I have told that they controls the flow of current by offering resistance. They controls the flow of current. They controls the flow of current by they controls the flow of current by offering resistance, and its units is ohm. Types, there are different type of resistors. What is the function of resistor? Offering resistance means they limits the current. Offering resistance means limits the current flowing through a circuit. Okay, that is the function of this resistor. Okay, then resistor. What is the unit of this resistor? It is ohm, or this is a simple for ohm. Then I have, as I have shown here, this is ohm. Ohm is a simple. This is simple for resistance, and Ohm's formula or Ohm's law. We can say that it is P is equal to IR. So it works on. So the resistor works on Ohm's law. Okay, that's why V is equal to IR. That's why we this unit is in ohms. And examples are this are used in voltage dividers. Actually, these resistors are used in voltage dividers, and there are different types of resistors. An example are fixed variable resistors are there. Fixed resistors are there. Variable resistors are there. Variable resistor example is potentiometer. Then thermistors are also there. Next, we are moving on to the next passive device, that is capacitor. Okay, capacitor, the function means it is to stores charges and smooths the voltage fluctuations, stores electric charge and releases it when needed. So as it is given here, you can see here that these capacitor types are here. Also here you can see it stores the electric charge and releases it when needed. That is, stores the charge and smooths voltage fluctuation. So actually its function is to stores the charge and smooths voltage fluctuations. Smooths voltage fluctuations. Voltage fluctuations. Stores the charge and smooths voltage fluctuation, and its units is farad or farads, and types are ceramic or electrolytic capacitors. You can see ceramic or electrolytic capacitors. Different types are there. Different capacitor types have been displayed uh, in this figure. You can see. Actually, this capacitors, basically a capacitor means, you can see in this diagram, it consists of two metal plates. Here in this diagram, you can see here. Moving on to this part, see, in this diagram you can see it basically consists of two metal plates kept apart by an insulating material between the plates. There is an insulating material between these plates and insulating material, and this place is used, it is, and this capacitor. So these are two metal plates are there. One is positively charged and the other is negatively charged. See, Q plus means positively. Q is the simple for Q is the you can say it is a unit for charge. Q is a simple. Q plus a small, either we will use small letter Q or we will use make use of Q, capital letter Q. So Q plus, one positive charged metal plate and another Q minus, that is negatively charged metal plate is being, and there is a dielectric. That means a dielectric means an insulating medium is there between these plates, and it is used to store and release charge when desired. And this is used to this capacitor is used to store and release charge when desired. When the battery is connected across the capacitor, see, a voltage is applied here. When a voltage is applied across the capacitor, what happens? This capacitor will get charged. The capacitor will gets charged. If the battery is removed, what happens? If we remove this battery, the capacitor discharges. So when an voltage is applied, it gets charged, and when this is removed, it gets discharged. Discharges. The capacitor offers low impedance to AC and high impedance to DC. So, due to this property, capacitors are used to couple AC signal from one circuit to another and to block DC signals. So, if we have to in a circuit, if we have to block some DC signals, so this capacitor is providing high impedance or hindrance to what high impedance to DC. So, in order to block DC, we make use of capacitor. So they are widely used in signal generation, tuning, filtering, and so on. And the value of capacitance is given by, you can see that the value of capacitor, the value of capacitor is given by an equation. C is equal to epsilon A by D, where epsilon is the permittivity of the dielectric. So permittivity of the dielectric. So this is the equation. C is equal to epsilon A by D. A is the area of the plates and D is the distance between the plates. So here capacitance means the value of capacitance is given by an equation where we call C is equal to epsilon A. Epsilon A means, where epsilon means the permittivity of the dielectric, and A is equal to area of the plates, and D is the distance, that this distance between the plates. And the value of capacitance is usually either it is expressed in microfarads, nanofarads. Microfarad means 10 raised to minus 6 F. See, I have given here that you can see here the farads. So value of capacitance is either in microfarad. That means into 10 raised to minus 6. 10 raised to minus 6 farad, or nanofarad, NF, that is 10 raised to minus 9 farad, or it is given in PF, picofarad, 10 raised to minus 12 farad. So picofarad is PF. So this is the equation. Then next we will. So what does this actually do? It stores electrical charges and releases it when needed. Another important thing is that it offers low impedance to another important point is that it offers low impedance to, that is it. Excuse me. Where, let me see where the point is. Yeah, the pencil is here. See, I'll move it to this part. There. There is a pen. Okay, it's going there. So you can see here as it is. So it offers high impedance to AC. So capacitor offers, sorry, low impedance to AC and high impedance to DC. So therefore it is used in filtering, signal generation, tuning, filtering, and so on. Next is that about inductors. What do you mean by an inductor? Inductance means the function is to step up or step down voltage. Actually, the basic function is, it is a property of inductors. The inductance means it is a property of inductors by which it opposes any change in the current flowing through it. So if current flows through something, it opposes the change of any current flowing through it. When a current flows through a coiled wire, an electromotive force generated in such a way that it opposes the flow of current. The inductors are generally specified by its inductance value and current capacity. So inductor stores the energy in a magnetic field, and when current flows through it, an electromotive force is generated in such a way that it opposes the flow of current. When a current flows through a coiled wire, an electromotive force is generated such that it opposes the flow of current, and the inductors are generally specified by its inductance value and the current capacity. The fixed value inductors are available in plastic capsules, which are very handy, and usually the values of such inductors will be written on it. Some manufacturers encode the value of inductors in colored dots. And the decoding is done in same way for resistors, that we will study later on. Here you can see coils in transformers are examples of. The unit of inductance is Henry, that is H is the unit of inductance, and the coils, and they are used in, inductors are used in coils in transformers and RF circuits, or radio frequency circuits. Okay. Next is the different types of inductors, and you can see here different cores can be there. Cores can be based on the type of core used. The inductors are classified as air core inductor, iron core inductor, ferrite core inductor, powder core inductor. Okay, some examples are given here in this one. Then fourth passive component that we use are transformer. So transformer is a device that consists of two or more coils. We told that when a coil is mounted and the current passed through it, we can call it as an inductor. And electromotive forces develop. But here, two coils. When two coils transfers electrical energy between circuits using the electromagnetic induction. Later we told that, sorry, not later, former we told that inductors stores the energy in a magnetic field, and when current flows through it, it stores the energy in a magnetic field. So what if two coils are placed uh, there? That means upward to two coils are placed back to back, or just like opposite to them. So it transfers the electrical energy between circuits using electromagnetic induction. And types of transformers are step up and step down transformers. So transformer is a device consisting of two or more coils and used to transfer the electrical energy from one coil to another. one coil, one circuit to another at different voltages without changing the frequency. There is no need of changing the frequency. Okay, without needing the change of frequency, and it works on the principle of mutual induction. What happens here? Mutual induction. Basically, a transformer consists of two inductors having the same coil. So, I already told you about inductors. See, you can see from the figure it says that there are two inductors having the same coil. It has two windings called a primary winding and a secondary winding. When there is a change in current in the primary winding, what happens? Uh, a magnetic flux is induced in the core. Since the core is common for the secondary winding also. See, please look here. You can see here. There is a primary winding. This primary winding and the secondary winding is there. Okay, basically a transformer consists of two inductors. See, look at this picture. You can see this similar. This is similar to the symbol of an inductor. Two inductors having the same core. The core is same. Say they are having the same core. And what happens? It has two windings called primary winding and secondary winding. When there is a change in current in the primary winding, when there is a change in current in the primary winding, there is phi is given, that is a magnetic flux is when there is a change in the primary winding, a magnetic flux is induced inside the core. Here the core is, it's an iron core. Here what happens is an air core, I think. So here a flux is induced in the core. And since the core is common for the secondary winding, see, the secondary winding is also having the same core. What happens? This magnetic flux that flows here, magnetic flux, it induces a voltage in the secondary core. It induces a voltage V in the secondary winding, not core in the secondary winding. The transformers are thus used in rectifiers, audio applications, and amplifiers, and are available in different shapes and sizes. Some of the common transformers are power transformers, uh, and audio frequency transformer, AF transformers, and high frequency transformers. Okay, these are some. So actually, what is the main purpose? It is step up and step down voltage. We make use of this transformers. So step up and step down. Okay, types of transformers are also given here: step down, step up, isolation type, single phase, instrument type, iron core type, ferrite core, thing type, and all. Okay, two windings are there. Next is the key difference between active and passive devices. Now we came across many active devices. What is a silicon controlled rectifier? CR is silicon controlled rectifier. MOSFET means metal oxide semiconductor field effect transistor. Then we versus that we studied about some capacitors, inductors, resistor, that being the passive components. Okay, next, we'll move on to the differences between them. Different features are being given here: active devices and passive devices. Some active devices are also given here in this figure. You can see what here. Here you can see. Here, see, active devices are given here. Transistor is an active device. It is simple for the transistor is given. See, at the same time, it has a transformer. That is a passive device. So don't confuse this with transistor and transformer. Then diode. There is a symbol for the diode is given. Diode symbol is given. LED. So earlier when I draw diode, I only do this much. Diode has a cathode and anode is there. So this is a symbol of diode. LED, photodiode. LED means light emitting diode. So LED is light emitting diode. That's why we gave this example like this, light emitting diode. Then photodiode works on, see, there is the arrow for the light is into this. So then integrated circuit operational amplifier is the operational amplifier. It's like 7 segment display, battery, and these are all active devices. They require an external power source. But passive means that is the first one, needs external power. Then next about passive resistors, LDR, right emitting thermistors. Hmm? Active devices means the function of active devices to amplify or control the signal. Then also the examples are transistor, diode, IC, etc. Then about passive devices, please see resistor and LDR. Then LDR, light detecting resistor, thermistor, capacitor, inductor, switch, variable resistor, transformer, and all. See, you can see the difference. Active devices, the power requirement is it needs an external power, whereas passive devices, no need of external power. Okay, function of active devices are to either amplify or control the signal. Then here, what is the functions? Passive devices either to store or dissipate energy. Then next, you can see the examples here down here. Examples. Examples for active devices are transistor, diode, and resistor. Then passive we have resistor, capacitor, and inductor. Applications of active and passive devices. See here there is one more thing, that is this is about tuning capacitor. This I mistakenly place this picture here. Sorry. So here in everyday life, active devices. In everyday life, we make use of this active and passive devices. And transistors are used in processors. Passive devices, resistors are used in the circuits. And LED bulbs, active LEDs are used in LED bulbs. These are light emitting diodes. So resistor, passive resistors are used in power supply. Radios are used in radios, we make use of active amplifiers. Tuning capacitors are used. Okay, in industries, communication system, active signal amplifiers, we use power supply and all. You make use of transformers and all. For acting as switch and all, we make use of BJTs. So different applications are there. Transistors, we make use of transistors as switches and all. Next is some MCQs related to this. Which of the following is an active electronic component? See, resistor is there, capacitor is there, inductor is there, transistor is there. From this itself, you can be sure that resistor, the purpose is to resist the flow of current. Capacitor stores and discharges current. Inductor induces stores electric current in the form of magnetic fields. See, then transistor. Transistor is the answer for that. Next question is, which of the following components stores energy in an electric field? Which of the following? Capacitor stores energy in the form of electric field. So in capacitor, we have seen that two metal plates are there. Two charged metal plates are there. Once a voltage is applied among this when the voltage is applied, so I'm just drawing a say voltage. When voltage is applied, this part gets what, if this is positive charge and this is a negative charge, this gets a positive charge, this gets a negative charge. But this plate will consist of, they're separated by a dielectric. This plate consists of what, plus 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 positive charges on the plate. This plate gets negatively charged, so minus minus minus. Electric field charges moves from positive to negative. So like this electric field, what is developed here? An electric field is developed. So this electric field, the component stores energy in the form of electric field. So what is the answer here? You can see here the answer is, the answer lies, where is the answer? The answer is here. Answer is stores energy. This is capacitor. Capacitor is the answer. Next one, a diode is classified as an active device. Why? Because it requires a power supply, it can amplify signals, it can control current flow, it only dissipates energy. Why do we call a uh, diode as an active device? Because an active devices are the devices which can control current flow. It can control current flow. അതുകൊണ്ടാണ്. So that's why we make use of this. We call this diode as an active device. Next one, which of the following is not a passive component? Which of the following is not a passive component? You have uh, transformer, capacitor, inductor, and MOSFET here. Transformer, capacitor, and inductor we have studied as examples of passive components. What is not a passive component here? MOSFET. What is the full form of MOSFET? MOSFET is metal oxide semiconductor. Metal oxide semiconductor field effect field effect transistor. So it is a transistor, not a transformer. So that's why it is the answer. Next one. An inductor stores energy in the form of, yeah, inductor stores energy in the form of magnetic field. So when current flows through a coiled wire, a magnetic field is developed. So that is inductor stores energy in the form of magnetic field. SI unit of resistance, ohm, everybody knows that. Which of the following components does not consume power in an ideal condition? Uh, in an ideal condition, which of the following components does not consume power? Resistor, inductor, capacitor. Both B and C. Yeah, the answer is inductor and capacitor does not consume power in an ideal condition. Inductor and capacitor. Which of the following components is commonly used for energy storage in a DC circuit? In a DC circuit, which of the following components are used? Resistor, inductor, capacitor. For storing, so transformer, another option. Which is the which of the following component is used for storing electrical energy in a DC circuit? In a DC circuit, that is capacitor. Okay. Next one. Which component is used for signal amplification? Yeah, resistor is there, capacitor is there, inductor is there, transistor is. The answer is transistors. Transistors are used for signal amplification purposes. A Zener diode is used for. Yeah, this is another type of diode. Later we will have a deep discussion on the Zener diode. Now we need the answer. Which SN diode is used for rectification, voltage regulation, signal amplification, power transmission. Zener diode that is used for voltage regulation. Then in an electric circuit, which component is responsible for voltage division? Yeah, in an electric circuit, the component responsible for voltage division is resistor. Which passive component is mainly used in a filter circuit? Which passive component is used in a filter circuit? In a filter circuit, the component used a passive component, diode, transistor, capacitor, MOSFET. See, diode is an active component, transistor, active capacitor is capacitor is also an active component. Is an active component. Yeah. Then what is, sorry, capacitor is also capacitor is capacitor is an which passive component is a question. Is capacitor an active or passive component? Capacitor is a passive component, and that passive component here which is used in the filter circuit is capacitor among these ones. Which of the following is an application of inductors? Which of the following is an application of inductors? Signal amplification, voltage regulation, high frequency filtering, none of the above. The answer is high frequency filtering. The role of a transistor in an electronic circuit is to amplify signals, store starch, convert AC to DC, limit current flow. The role of a transistor is to amplify signals. Which device is used in power supply circuits to step up or step down voltage? Yeah, very easy. Transformer. Don't confuse it with transistor. It is transformer for step down and step up and step down of voltage in power supply circuits. Which semiconductor device is used as a switch and an amplifier? Transistor. Switch and amplifier. Transistor can behave as both a switch and an amplifier. What is the main purpose of a resistor in a circuit? To limit the current flow. Okay, to limit current. Which device allows current to flow in one direction? Diode. Which of the following components blocks DC but allows AC to pass? Capacitor. Capacitor have high impedance to DC but low impedance to AC. So capacitor blocks DC and allows AC to pass. So capacitor. Which active component is used in digital logical circuits? Which active component? Inductor, diode, transistor, transformer. Transistor. digital logical circuits uses transistors. Thank you. So we have finally discussed everything regarding our course on the first essentials of electronic engineering. The first topic in the exam for the exam lecturer in Polytechnics, the first topic is for electronic engineering, it is active and what are active and passive devices. Now you have got a clear idea on what are active and passive devices. So I'll be concluding the class with this lecture. Stay tuned for the next lectures. If you like the class, please give up. So please give. If you like the class, do not forget to like and share and subscribe and revise the lecture and practice MCQs. Like, share, and subscribe to my channel. Thank you so much for listening to me. This will help you prepare for your exam. Thank you.